Pranams to all. So in this video we'll be learning how to solve this heartfulness themed Rubik's Cube which was available at Kanha Shanthivanam during this September 17 Bhandara. Now before learning how to solve this, I strongly recommend you to learn how to solve the normal Rubik's Cube, which is this. So I've given all the links in the description. There are about 7 links. It is all just one tutorial split into 7 segments. So I've given it in order in the description. Please check it out and go by order. Learn all the steps. So once you're confident with solving this, you can learn how to solve this. Before moving on to the tutorial, one humble request is that let's all use this cube always on top of a table or a firm surface, and let's not use this on floor or elsewhere, to pay our due respect to our beloved masters over here. And more importantly, if your pieces fall off like this, it is quite fixable in the cube. All you have to do is, this is called a corner piece. It's got 3 images and this is an edge piece. So first we'll be fixing all the corner pieces. So this one goes here, you can just slide it in, and this one goes here. And in order to fix the edge piece, the face which is yet to be fixed, you have to tilt it towards 45th degree, like something like this, and you can just push this in. It goes back and it's quite fixable. Even if any tile comes out like this, it is also quite fixable. You have to know or memorize the image pattern. The image has some directions, so you can quite figure that out from this video. So you can just push those tiles back in even if they go wrong. So assuming that you have learned how to solve the regular one, I'm going to go to this. So there is not much to learn if you can already solve this. If you can solve that, you are going to learn only some few special cases which you will be encountering this puzzle. So I have scrambled this puzzle. Now the major difference between these two puzzles is you have color but you have a face here or a logo. So these colors do not have directions, but the images here have. So there are various methods with which we can solve this, but in order to avoid confusions, we can go with this method which I am going to demonstrate. So basically this is going to be the bottom layer and this is going to be the top layer. Now while solving the cross, it is advisable to have all the center pieces aligned, but that might be a little bit difficult if you are a beginner. So I would recommend you can just solve the cross without bothering about the center pieces. Now we have the cross, and then let's go to the corners. Now this corner has to come here, or if you have learnt it like this anyway. So we are going to solve the other corners as well. So this is another corner, it has to go here. It is here. This has to go here, and this has to come here. So we have done all the corners. The first layer is now done, but the centers are misaligned. That's not an issue right now. Let's deal with that later. Let's move on to the second layer now. So we have one piece here which has to go this way. So let's use that algorithm, and this one is there which has to go here. These two, okay, this one is here which has to go here, and this one has to go here. So the second layer is now solved. 2 layers are completed. The third layer, where we get a cross on top first, the OLL, 2-look OLL, and the second look we complete the corners. Now there is a cross with 2 corners already. Now these 2 corners are away from the top layer, so using that case the OLL is done, and finally the PLL is here. Okay, it's an A perm. If you are doing 2 loop PLL, it's fine, you can go with your flow. So once you are done with solving all the pieces, now you are left with just solving the center pieces, aligning the center pieces, for which we are going to use only one single algorithm. It is called the T permutation. Now if you have learnt the 2 loop PLL, which is the last step in the 3x3 CFOP solution, you probably know how to solve the H permutation, UA and UB and Z permutation. This is the H1, swapping these two and these two. It goes something like this. So these two and these two are swapped. Now the T permutation is a case which is from the full PLL. If you are not aware of that, that's not a problem. You just have to learn this T-perm algorithm in order to solve the centers, align the centers. Now this is going to be the bottom layer, this is going to be the top layer. We will never rotate the cube this way or this way, but we can rotate this in this direction, the y-axis. You will understand that later. Now we are going to see which pieces are misaligned. In this case, all the pieces are misaligned, but that's not a problem. Let's start from here. If you just look at this logo, you can easily figure out that this piece is going to have to come this way. It has to move in this direction. So in order to do that, before performing the algorithm, we are going to bring this on the top layer. You can do M2 slice so that it is on the top layer now, and we will perform the algorithm. Basically the algorithm is something like this. If you do this in a solved one, you will arrive at the same case, which is the T permutation, and if you do the T permutation algorithm again, it will go back to normal. So what happens when we do a T perm case is that if you look at it, this red has to go here and this orange has to come here, and this yellow piece has to go here, so that yellow, orange, blue, and this one has to come here. So basically a T permutation case is going to be like this, swapping these two corners and swapping these two edges. It goes something like this: R, U, R dash, U dash, R dash, F, R2, U dash, R dash, U dash, R, U, R dash, F dash. By doing this, we can swap these two and these two. But if you think how it is related to solving the center in this one, well, if you do the T-perm twice, this piece is actually shifted 180 degrees. But we cannot see it in this one because it is just a color. But when it comes to images like this cube, we can easily see that this piece is in the wrong way. So that's the basic issue. We can use the same T-perm. We know that it is going to tilt it like 180 degree or any other 90 degrees. So we'll be using this T-perm so that we can get all the pieces aligned to one direction. Now this one has to come in this way, the counterclockwise direction. So I'm going to just start executing the algorithm from this. Now it was basically here. We did a M slice to get it on top, and now we'll be performing the algorithm, the T-perm. So I've done it once. It is now facing here. So again it is facing here again. Now if you have noticed, this was primarily in this way, but it has gone through a 180 degree shift because we have done it twice or even number of times. So again I'm going to do the same, and now it is solved. It is aligned with these two, which means it will be aligned with these all the pieces. So that's how we do this. After doing this piece, we are going to just return it back to its original state. Now this layer is completely solved. Moving on, we have some more pieces. Now this piece is in the wrong way, so we'll get this on top and start doing the algorithm. With just one time it is aligned, so we can just bring it back to the normal position. Now this is done, and I would recommend you to first solve the bottom one and then the side pieces and then come to top. So we are going to do this one. We can bring this piece like this. It is on top now, and perform the T-perm until it is aligned. Now it is aligned. We can bring it back, and this one has to be aligned, this one has to be aligned. We can get it on top, start executing. No, no, yes. So we can bring it back. Now if you notice, we have done it thrice, this particular piece. So if you do it twice, as I said, the T-perm, if you do it once, you arrive at the case itself. If you do the T-perm case again, you can solve the cube back. But we have done odd number of times. We have done it 3 times for this piece, which means now these two and these two are actually swapped. You can look at this piece has to go here and this piece has to come here, and these two pieces have to be swapped. So here what we have to do is, now the next piece I'm going to solve is this. I know that. So I cannot directly come here and put this on top, because if I do it from this way, now this is not solved. So if I start from here, I'm going to swap these two and these two, which I don't want to. So in order to have it in the same way, like not messing up these two and these two, I'm going to do something like this. I'll bring this piece first here, which is I'm doing, please watch this move correctly. I'm going to bring this piece here, and then I'm going to get this piece here. Basically I'm pretending this piece was here by just doing a setup move like this. This is called a setup move. Now from here it is now here. I'm just pretending that this piece is this piece, so that I can just put it on top. These two are this two and this two. These are already in the wrong way. So if I do it one more time, first these two and these two will get swapped and get to the correct place. Because if you do the T-permutation algorithm in even number of times, you will certainly arrive at the starting position, which is actually the solved state. So I have done that, and you can just see every image here is in the same direction, which means this piece is also aligned while doing the T-perm. We just did it. So you can just bring it back, and we were pretending that this piece was this piece. We can just bring it to the normal position, and we have the last one. It is on top, so it is very easy. You can just start from any face. You can just see and find that this is a 180-degree shift. So we are going to do twice the T-perm algorithm. It goes like this. So it has come here from this way, and again. So that solves the center. This way you can solve all the center pieces, but this is actually a little longer method. The shorter method would be little bit difficult to understand in the beginning level, but it is just this. If it is scrambled, you have to figure out a way that while solving the cross, or the second layer or the first layer, you should never make any misalignments in the centers. So I'll just do a walkthrough solve. You might not understand in the very beginning, but you just watch this video again and again, and at one point you will figure out what is that. So this is how I solve this puzzle. I never do the centerpieces in the last. I try to do all the centers in the first place, so that finally I'm just left with the last layer misalignment, which might always occur. So okay, now I'm going to start with the cross. First I'll just align this to this image. This has to come here, this has to come this way, as I said before. So this piece I'm going to have to bring it here. So I'll not directly bring it like this. Instead I'll tilt the center and bring the edge piece, so that when I solve this edge, this center is also aligned in the right way. The same way I have done this one, the same way I'm going to do this. And this one. Now this might be a little difficult to follow, but if you keep watching this video and practice the same, at some point you will figure out this, if you are a beginner. So I have done the cross now. At the same time, all the centers are in the right way. So let's move on to the corners, but I'm going to do something else. I'll just solve the two layers. This is basically some advanced method where you can directly solve two layers without doing just one corner and then the edge one. So I have done two layers now, and at the same time I have not misaligned any of the centers. Now we have the third layer. We are going to do the OLL. So the OLL is done and the PLL is also done. Just skip actually. So this time I didn't have any center alignment issue, but basically at the most I'll have only this issue where every other center is in the right way and only this center is having a 180-degree shift. So if you follow this method of having all the centers aligned while doing each and every piece, you might only encounter this one and all these other pieces will automatically be solved. So sometimes you will get this, and sometimes, like how I got now, you might not even get this alignment issue. So even if you get it on top, you can do the T-pound twice and solve the piece. So this is how you solve it. Hope you understood how to solve these special cases, the center alignments. If you didn't follow, you can just rewatch the video and understand. Thank you.